Let's calculate a double integral, shall we? As always, the very first step is going to be turning the dA into either dx dy or dy dx. Now, when I say dx dy or dy dx, what that essentially means is which one we're going to be doing first. The one that's written closest to the integrand on the innermost portion of it is the one that's done first. This one would be pretty much as easy one way as the other, but I'm going to choose to do y first. So we'll do dy dx. This means that the inner is going to be the y. And so we'll be integrating along, well, this is the x and this is the y. So integrating from 0 to 1 along the y. X over 1 plus xy dy. You may recognize this as a u substitution problem, and you'd be right. If you put u equal to 1 plus xy, then du will be equal to x dy. And if you recognize x dy from here, you're absolutely right. So this then equals integral of du, that's the x dy part, over u. Now for the limits of integration, we're going to plug in 0 and 1 for y in the expression for u. So u of 0 is 1 plus 0, or simply 1. U of 1, remember that we're setting y equal to 1, so this becomes 1 plus x. It is okay for this limit of integration to contain an x. In fact, that's what we want, because we want the next integral, when we go to evaluate the outer one, to involve an x to give us a variable to integrate with respect to. This is going to be ln of u evaluated at 1 and 1 plus x. Sometimes we worry about whether it's ln of absolute value of u, but when we're only looking at a positive domain, we don't have to get involved in those kinds of thorny questions. So it's okay to just have ln of u. This is ln of 1 plus x minus ln of 1. And all good boys and girls know that ln of 1 is 0. And so that goes away, and this is simply equal to ln of 1 plus x. This now will be the object of the outer integral. For the outer, we're integrating now with respect to x. So we did the dy, now we're doing the dx. X goes from 0 to 1, that's according to this. So integrating ln of 1 plus x dx from 0 to 1, whenever you integrate an ln function, you have to use integration by parts, unless you happen to know the formula by heart. But we're going to do it by parts, just in case you don't remember it off the top of your head. By parts goes like this. U and dv are chosen to compose the entire integrand. U should have a simple integral. U should have a simple derivative, and dv should have a simple integral. U being equal to ln 1 plus x, and dv being equal simply to dx, does cause this to happen. Like what you need is for u dv to give you everything that shows up here. And as long as we pick our u and our dv to be these two things, that's good. It composes the whole thing. So the power of integration by parts is that you use the u and the dv to calculate a du, which in this case is dx over 1 plus x, and a v, which in this case is x. Notice how I differentiated u to get du, and I integrated dv to get v. This then is going to be equal to uv minus integral of v du. We'll worry about the limits of integration in a minute. But for now, we're going to put those values that we got for the u, the v, the du, and the dv into this formula. uv is going to be x times ln of 1 plus x. That's the uv part. and then integral of v du. This will be x over 1 plus x dx. The second integral still seems kind of difficult there, but here's a trick. This is something that you'll really be able to apply very well, not just here, but broadly. The problem with this is that it seems to be upside down. If the bottom is in two parts, that's a problem. If the top is in two parts, but the bottom is in one, that's okay. Here's how you can fix it. Say that u equals x plus 1. Then, of course, du equals dx. But now we get to write this in a much more convenient way. So this here, this integral, is going to be integral of x is now u minus 1. And 1 plus x, well, that's the same as x plus 1, or simply u. Clever, huh? And now you get to separate it out because now you can just divide by the bottom. So then this is integral of u over u, which is 1, minus 1 over u du. This is an integral that you do know how to evaluate. So this whole thing is going to be equal to x times ln of 1 plus x minus, and now I'm going to integrate that thing. It's going to be u minus ln of u, right? Well, you'll notice that at this point I've got x's and I've got u's. That's not the greatest outcome. So what I'm going to do is, went down too far. What I'm going to do is put this back in, put the u back in so that everything is in terms of u again. Well, now it's going to be possible to evaluate it just on the basis of the original limits of integration. See, sometimes when you do a substitution, you change the limits of integration, but sometimes it can be convenient to be able to go back and put in the originals, especially when you've got more than one method going on. Like this, we had integration by parts, followed by integration by substitution. So this here, oh, I love all these colors. This is going to be, let's try this one, shall we? This is going to be x times ln of 1 plus x minus, and now I'm going to put in the thing for u. That's x plus 1 minus ln of x plus 1. Now this whole thing is the antiderivative. We did a bunch of different methods. We used integration by parts, and then we used integration by substitution. We got this as the antiderivative. So this is the thing that will get evaluated at 0 and 1 for the x values. See how it was important for us to change back to the original variable? So this is going to be, it's a little messy, but don't worry, it's going to work. We'll plug in the 1. 1 times ln of 2. After all, 1 plus 1 is 2. Minus, and then 1 plus 1 minus ln 2. That means the 1 has been taken care of. Now we'll do the 0. Minus, and now I'm going to plug in 0 everywhere. 0 times ln of 1, because 1 plus 0 is 1, minus 0 plus 1 minus ln of 0. Oh, oops. Ln of 1, because 0 plus 1 is 1. Okay, lots and lots of simplifying here to do. In the first term, the first set of brackets, we've got ln 2 minus 1 plus ln 2. And then I'm just going to beam the minus sign here through the second set of brackets. I've got this, which is 0. Then this is 0. This is also 0. So at the end of the day, the second set of brackets ends up being minus 1 or plus 1. Now I'll collect everything together. We've got 2 ln 2's. So it'll be 2 ln 2 minus 1 plus 1 ends up being minus 1. And here's a cool party trick. You don't really have to write 2 ln 2, because remember that you can use laws of logarithms and bring this to the inside to get ln of 2 squared or ln of 4 minus 1. We could go back and check to make sure that we would get the same result with the other order of integration. But I think that this is going to be messy no matter what. So let's just call it like well enough that we've done it this way.